sublevel as s orbitals, and we know they are spherical. Okay, here's our little experiment we're going to do together. If I hold this up in the air, we are going to pretend this is a perfect sphere. There's no little stick here that I'm hanging on to, and this is perfect. There's no bumps, indentations, or anything. I'm going to hold it up here. I'm going to ask you to close your eyes. You don't really have to. Okay, if I asked you to close your eyes and really did it, and I turn this while your eyes are closed, and then I say, open your eyes again. If it's a perfect sphere, could you tell I had turned it? No. If you got a sphere, it just goes out in space, and there is no up, down, sideways. So there's only one orientation in space for a sphere. Now, on the other hand, do you have those pictures in? On page 155 in your book. Remember when we started talking about p orbitals? P orbitals always come in sets of 3, and they're found at 90 degrees to each other. That's just what's found. Why they're that way, who knows. Okay, you have one along the x-axis, one along the y-axis, one on the z. Now let's go to the Mars. Okay, I have one p orbital. One meaning how many I have. You know, we don't have any on the first major energy level. So this is just a p orbital. I'll say it that way. Okay, let's do this same experiment. I'm going to hold this one up in the air, and I'll ask you to shut your eyes. And while your eyes are shut, I'm going to turn it this way, and then I say, open your eyes. Have I done anything to it? Well, if you have any sort of short-term memory, okay, it started out up and down, or vertical, to you educated people. Okay, so it starts up and down, but while your eyes were closed, I turned it sideways. That's a different orientation. Okay, and if we did it again, I could also turn it this way. So if you have a p sublevel, where there's going to be 3 p orbitals, there are 3 orientations in space. Up and down, sideways, in and out. And so we're going to have 3 values of m sub l to indicate the 3 orientations in space. Now when you get up here to the d's, remember d's are really like 2 peas put together, or a 4-leaf clover. If you looked at the pictures here, and they have designations that we don't need to worry about, but there's 1, 2, 3, 4, and there must be one off the side here. There's 5 different orientations for that. Now let's draw a picture, and we can put this story all together. Let's go back to the box diagrams. Remember, energy is increasing this way. This was the 1s, we have the 2s, we have the 2p, we have the 3s, we have the 3p. What comes after 3p?
4s.
4s, good. 4s. Then we go back and pick up the 3d. Okay, now, in the old talk, I could call this orbital the p sub x, this one's the p sub y, and the p sub z. Usually we don't mess with that, but those would be the 3 designations. Now, in the new talk, we're going to use m sub l values. Okay, we've got 3 orientations. If I'm in a p, hang in. If I'm in a p sublevel, L is equal to what?
1.
1. Okay, what can m sub L be? It can be minus L, up to 0, up to plus L. So we come over here, this one, and it's like a number line. M sub L is -1. Here it's 0. Here it's +1. This is, let's go down here. If you have only an S with only that one orientation, M sub L is always 0. Okay, so here in this S, M sub L is 0. Here, M sub L is 0. Then I get up here, M sub L. What will this first one be? -1 to what? 0 to +1. M sub L for this one, 0. Okay, now, a neat trick. If you can't remember the math talk here of what M sub L can be, like the math talk here, here's what you can do. If this doesn't do anything for you, if you use a box diagram, take the center orbital, make it 0. Build a number line. Go down, go up. So take a wild guess. Meredith, hit it.
Okay, so the zeros in the middle,
Zero's in the middle.
and then you do -1, and then -2,
Okay.
and then +1,
Mhm.
plus.
Excellent. Excellent. Now, I have one electron right here, and I would like to know its address. Okay, so right now, we can talk about it. We can talk 3 quantum numbers right now. Now, in the old talk, I'd say, okay, I got hydrogen. What's its electron configuration? And you all would say 1s1. Okay, new talk. We just shifted gears. I want to know N, L, and M sub L, that guy's address. Okay, N would be what?
1.
1. Why is it 1, Bruce?
Because it's on the first.
It's on the first major energy level. I see some furrowed brows. Can you ask anything right now? The first part of the address just tells you major energy level. Okay, we're on the first major energy level, N is 1. Okay? Now, I'm in an S sub-level. So Meredith, what's L?
0.
0. Good. All right. How about orientation and space, Peter?
0.
0. That's the first part of that guy's address. Well, the first 3/4 of that guy's address. Okay. Since every electron in there has to have its own fork or its own particular address, then we need a 4th quantum number. And it's referred to as M sub S, the letter S. And the allowable values, there's only 2, plus or minus a half. And what does this tell us about? It's called the spin quantum number. Just a little bit ago, we reviewed, why did we use the half arrow up and the half arrow down? Because how do 2 negative charges live together in peace and harmony? They must rotate, or at least it's an explanation. They rotate in the opposite directions or spin in the opposite directions. So by convention, the first guy in is the half arrow up, and you give it the plus. Up is good, so it's positive, plus a half. So that's the guy's address. Now, what do we do? What if I were doing helium? Is everybody okay with that first one? Okay, now I've got helium. What would be its electron configuration? This is last Tuesday, and I'd say, what's the electron configuration, Nina? 1s2. Yeah, 1s2 is helium. If I do the box diagram, it looks like this. Okay, so I can't just say, what are the quantum numbers for helium? I've got to say, I want you to do this electron or that electron. I've got to specify. Generally, what we do is, what is the last electron? So I want us to do that guy. Okay? We did the first guy. So now I want his address, the circled in blue. N is 1, because we're still on the first major energy level. L is 0, because we're still in an S sublevel. M sub L is 0, because it's always 0, because there's not but one orientation in space. So they just say no other changes is really kind of what they're saying. And then M sub S for this guy, minus a half. Because you're the second guy in. Going down is bad. Going up is good. Well, if you think of positive and negative. First one in is half arrow up, and that's strictly by convention. Half arrow up, and we call it plus a half. We really want to indicate their opposites, to indicate that opposite spin a little bit. Now, let me ask you a thought question. And this is really where you can tell me how smart you are. Okay, and some of people get it at first really quick, and some take like 24 hours, they've got to sleep on it. Okay, I have an atom, and it's got lots of electrons. Okay, and each electron would have its own 4 quantum numbers, right? Okay, because that's the specific address. Okay, I have this big, big atom with lots of electrons. N is equal to 2. How many electrons can share that address? N is equal to 2. How many electrons can share that address? 8. Excellent. My class yesterday didn't have a clue. You're wonderful. Okay? Because what are you saying? In the old talk, I could have said, because if I'd asked you in the old talk, you would have nailed it, probably the majority of you. In the old talk, I would have said, we are on the second major energy level. How many electrons can fit their maximum? 8. Because we had that delightful little expression. Anybody remember it? 2n squared. And that tells you the maximum. Okay, 2n squared. I said you were on the second major energy level. N is 2, and then we square it.
Is that where the N came from to begin with?
Yeah,
The quantum
yeah.